Hello, good morning. Good morning, Charan. Good morning, Sushant. Okay, let's start now. Okay. Right. We were discussing about the conductor, isn't it? So now we'll discuss about what will happen when the two conductors are connected, right? So how the distribution of charge will take place, isn't it? What will be equal? What will be in the ratio of radius? That is what we have discussed in the last class, right? Okay, up to this we have discussed. Questions based on the energy conservation, right? Distribution of charges. Okay, let's take one example and then we will continue with the next part of this chapter, which is the capacitor part. Okay, in this example, what is given to us? Two spheres are given to us. Okay, two spheres are given to us. Conducting spheres are given. Okay, radius of this one is what? 2 centimeter, and this one was given as plus 6 coulomb of charge. There is another sphere. Radius of this one is 4 centimeter. Radius of this one is 4 centimeter, and it was given minus 2 coulomb of charge. Okay. Now they are connected to each other with a conducting wire. Okay. So we have to find final charge, final charge on both the sphere. Okay, both the sphere after equilibrium is reached. Sometimes they will use the word electrostatic equilibrium is reached. So electrostatic equilibrium means what? When the potential become equal for both the sphere, that is called the electrostatic equilibrium. It doesn't take any time, it is instant process. Okay, this achieving the electrostatic equilibrium by making the potential equal, that is just an instant process. The moment you will connect these two conductor with a conducting wire, instantly what will happen? The charge distribution will take place and it will achieve the equilibrium condition. So find final charge on both the sphere when electrostatic equilibrium. Okay, equilibrium is reached. Okay, so please tell me what will happen. What will be the charge on these two spheres when electrostatic equilibrium will be reached? Will you try this once? Please tell me. Not very difficult question. Please tell. Please tell me, all of you, can you do it? See, once the equilibrium will reach, what will happen? One of the sphere will give some charge and other sphere will receive the same amount of charge, right? So what I am considering, once equilibrium is reached, this has how much charge? 6 minus x charge is there, okay? Means from this sphere, I am considering the x coulomb of charge is gone. So how much charge will be coming here? Minus 2 plus x coulomb will be there, isn't it? And what charge it will have? It will have 6 minus x coulomb charge we will have. Up now, equilibrium has reached, so potential should be what? Equal to k into 6 minus x by radius. Should it be equal to k into minus 2 plus x divided by what? The radius of this one is 4. K got cancelled out. 2 into 2 we have. So 2 into 6. 12 minus 2x equal to minus 2 plus x. So what we have here, if you check it, 12 minus 2, that is 14. है ना? 12 minus of minus 2, 14. X minus of minus, so 3x. So what is the value of x we are getting? X we are getting as the 14 by 3. The value of x is coming how much? 14 by 3. That means finally sphere 1 has what charge? Sphere 1 has charged 6 minus x. The x we have calculated as 14 by 3. So 18 minus 14, 4 by 3 coulomb charge is there. And sphere 2, the other sphere has what charge? Other sphere has charge minus 2 plus x. X means 14 by 3. So 3 into 2, 6. 14 minus 6, 8 by 3 coulomb of charge. Okay, understood. So in electrostatic equilibrium, what happens? In the electrostatic equilibrium, if a conductor is given, okay na, if a conductor is given, then conductor surface acts like a equipotential surface. That is the one thing about the electrostatic equilibrium. And the second thing, if two conductors are if two conductors are connected, है ना, with the help of a conducting wire, then what will happen? Then both the conductor will have charge in such a way that the potential of both the spheres should become what? It should become equal. Understood? So this is a way to charge the body also. Means let's say one is a charged body and second one is a neutral body. Okay, let's say two conductors are there. One is the charged conductor, other one is the neutral conductor. What will happen if you connect them? Again, from the charged conductor, some of the charge will flow to the neutral conductor, है ना? And then the neutral conductor will also get what? Charged. Understood? So that is another way of what? Charging a conductor also. Okay, this process is called as the conduction of charging with the help of what? Conduction. Clear? Please tell me. Up to this part, is this clear what we have discussed till now? Please tell me. Clear up to this what we have discussed? Let's do one last example on this one. In the question given to us, two spheres of equal radius. Okay, question gave what? Both the sphere are what? Of equal radius given to us. Okay, one has charge plus q, other one has charge plus 2q. Both the sphere has what radius? R radius each. Okay, let's call this as the sphere A. This is the sphere B. Now, there is a third sphere, identical sphere. Means what? This third sphere is also what? Same radius, but it is neutral right now. Okay, this third sphere is what? It is neutral right now. What happened? These two spheres are what? Some distance will be there. Let's say some distance x is there between them. Now what happened? This third sphere or C sphere, first it is brought in contact with A, right? Some charge transfer will take place between A and C. And then again, that same C sphere is brought in contact with B. Then what will happen? Again, some charge transfer will take place between the B and C. And again, this the C sphere is what? Taken away. So now we have to tell that what is the new force between the A and B sphere and what is the charge on the C sphere. Understood the question? The question says, right, a third two sphere A and B of equal radius, charges are given as Q and 2Q, are kept some distance apart from each other. A third identical sphere, okay, sphere C, okay, identical. C is a neutral one, okay, na? C is initially a neutral one. A third identical neutral sphere C is brought in contact is brought in contact with A and B, okay, successively. Okay, you have to find out two things. Find first thing, charge on the sphere C. Okay, charge on sphere C after both the contact has been done. And the second thing, new force between what? Between A and B. Right now, what is the force between A and B? So right now the force between A and B is K Q 2Q by x square. And when C will be brought in contact with A and B, then what will happen? Some charge transfer will take place, na? So because of C is brought in contact with A and B, now A and B will not have the same charge as Q and 2Q, which is right now. It will change, and because of the charge change, what will happen? The force between them will also get changed. Is that clear? So please tell me what is the answer we are getting for this question. All of you, please tell me, are you understanding? Any doubt or confusion there? Please tell.
No, sir. Sir, if
Right.
the
Chaliye, so,
charge on C
yeah,
is 4,
tell me what we are saying.
if the charge on C is 5Q by 4,
5Q by 4. Let's see. अब you see, in this question, what is given? All three are identical one. So what we will do it, whenever I will bring in contact with each other, I can say the charge is going to be what? Half of the total charge, isn't it? Total charge so will remain constant, na? Total charge between A and C in contact will remain constant. The total charge is Q. Now both should have equal also. So that means what? Half charge should be on both of them. So that's why when A and C are brought in contact, for A and C, what we can say? Finally, the charge on A is what? Half of the total, isn't it? And C has zero charge initially. A has Q charge. So finally, A will have Q by 2 charge and C will have also what? Q by 2 charge. Now we are going to do what? Now we are going to bring A and B in, sorry. Now we are going to bring B and C in contact, okay? Now what we are going to do? B and C in contact. But for this step, what will happen? Now, what is the charge on the B? The charge on the B is 2Q. No problem. But now, is the C is neutral now? Is the C is neutral now? No. Now the C is having Q by 2 charge. Understood? And then they are brought in contact. So what will become? After equilibrium, what will happen? 2Q plus Q by 2. है ना? B has this charge, C has this charge, and after they are brought in contact, what is the finally charge on B and C? So 2Q plus Q by 2 half, right? So 2Q plus Q by 2 means 5Q by 2. So B will have 5Q by 4 and C will have also 5Q by 4 charge. Understood? So this is, understand the process here what happened. If you want, you can do it like this also. Initially, A has Q charge, C has zero charge. When they brought in contact, what happened? A becomes Q by 2 charge, C become Q by 2 charge. Understood? So this is what the final charge distribution is there. So finally C has what charge? The final charge on the C is what? It is 5Q by 4. Now new force between A and B. What is the force between A and B right now? What is the force between A and B right now? It is K Q 2Q by x squared. We did not change the distance. Okay, now we did not change the distance. And later, when the distribution of charge has been completed, what is the new force between A and B? So it will be K. What is the new charge on A and B? So A has finally charge Q by 2, B has 5Q by 4. So K Q by 2, 5Q by 4 divided by x square. What we are getting? 5 by 8 K Q Q by x squared. Understood? So this new force is what? You can also say that this new force is 5 by 16 times the old force. Understood? So if they ask you what is the ratio of the force earlier experienced by this sphere and finally experienced by these two spheres, so that ratio also we can calculate it now. Okay, understood? So these are the conductor. What is the purpose of a conductor? The purpose of a conductor is what? To store charge, to store what? The energy. Is that clear? So next part is what? We have an instrument, okay, electrical instrument called what? The capacitor. So actually we have three type of capacitor with us, okay. What are the three type of capacitor we have? Three type of capacitor we have called parallel plate capacitor, spherical capacitor, and a cylindrical capacitor. What is the difference between these three type of capacitor? Tell me. And what is a capacitor? So capacitor means what? It is a device which stores energy. Okay, what is a capacitor? Capacitor does what? It stores what energy, but which form of energy? It stores electrical energy. Okay, it stores electrical energy whenever it is connected in a electrical circuit. Clear? Whenever we will connect a capacitor with a battery, what will happen? It will store the electrical energy. So how can it store the electrical energy? So if we want to store the electrical energy, what does it mean? That means some kind of electric field should develop, isn't it? Some kind of what? The electric field in a region should develop, isn't it? And if electric field is there, then we can say that if a charged particle enters that region, because of electric field work, that charged particle can gain some of the kinetic energy, or one form of the energy we will be able to convert it into what? The another form. But for that, what is needed first thing is we need the electric field in that region. Understood? So capacitor is what? Capacitor is a device which stores the electrical energy. Okay. How many type of capacitors we have? So we have actually three type of capacitors. Okay. We have how many type of capacitor? Three types of capacitor is there. First one is the parallel plate capacitor. Okay. First one is what? The parallel plates capacitor. Second one is what? A spherical capacitor. What is the difference in these capacitors? Can you tell me? Can you tell me what is the difference in these capacitors? See, the difference in these capacitors are just simple that what is the shape of a conductor? Capacitor is always formed with the help of what? The conductors, okay? So in parallel plate capacitor, what happened? The conductor shape is in the form of two parallel plates separated by a small distance. A spherical capacitor, what will happen? Here we are going to use the conductor in the shape of what? The concentric sphere. And in case of cylindrical capacitor, so we are going to use the conductor in the form of what? Coaxial cylinder. Understood? So all these capacitors are having same property to store the energy, but depending on the shape of the conductor, size of the conductor, है ना? We will have different capacitance. The capacitance is what? Capacitance, it defines mathematically that how much energy it can store. A conductor cannot store infinite energy. There will be a certain limit up to which a conductor can store the energy. So what is that limit is calculated? That limit is calculated with the help of what? The capacitance. Understood? Please tell me. Please tell. Clear up to this? Please tell me. Everyone there in the class or not?
Yes, sir.
All of you there or what?
Yes, sir.
Right. So parallel plate capacitor or a spherical capacitor or cylindrical capacitor. So any given capacitor can store how much energy. That is what decided by the capacitance. Okay. So what is the capacitance and on what factor the capacitance will depend. So let's say two parallel plates are given to us here. Okay. And you see, if you give the charge to these two plates, what will happen? Potential difference will develop now. Please tell me, if you give some positive charge to this one and negative charge to this one, what will happen? A potential difference will develop between them. Now you see, the more the charge you are going to give, can I say that more potential difference will develop? Or another way you can say that more potential difference you will create, है ना? The more the potential difference you create in the region, right? The more charge will get accumulated on the plate. So, can I say charge accumulated on this conductor is going to be proportional to what is the potential difference applied? And that constant of proportionality is called as what? The capacitance. So capacitance is what? Capacitance is charge divided by what is the potential difference applied for that charge. Or if you have given the charge, how much potential difference is developed. Or you have applied the potential difference, how much charge got accumulated, because charge and potential difference are related with each other. So don't think that capacitance is depending on the charge or capacitance is depending on the voltage difference. Why so? Because if you change the voltage, charge will also change, so that capacitance remain unchanged. So that capacitance remains what? Unchanged. Is that clear? So what happens here? The charge and potential difference are related with each other. Okay. So here the charge is changed, potential difference is also simultaneously changed. So on what factor the capacitance depend? So capacitance depends on what? Capacitance depend on shape and size. Capacitance depends upon what? Capacitance depends upon few things. First one, shape and size of conductor. Okay, shape and size of conductor. That is the first thing. Second thing is what? First thing clear? Shape and size of conductor. Second thing is what? The medium. Medium also affect the capacitance. Okay. Medium between the medium in the space, or you can say that medium in the space between the conductor. Understood? Between the conductor. Understood? So the conductor plates are given to us. What is the space filled in between? Okay, what is the space filled in between? So that space also decide about that. That medium property also decides about what? The capacitance of a medium. Is that clear? So now, if we are going to calculate the different type of capacitance, let's first discuss about the parallel plate capacitor. What is a parallel plate capacitor? It's the simplest one. Why? Because here, what we have, the conductor surface or the conductors are in the shape of what? Two parallel plates. Okay, conductors are in which shape? Two parallel plates are there, something like this. Okay, let's say we have given the charge to this one plus q, and here we have given charge to minus q. Okay, so what will happen? This positive plate will create the field in this direction, right? Negative plate will also create field in which direction? In the same direction or not? So if you calculate the net field here, how much the net field will come? The net field will come here. If I calculate the net field, will it come? Due to positive plate, it will come Q by A. A is the area of the plate. So that is sigma by 2 epsilon naught plus. Due to negative plate, same thing. Q by A sigma by 2 epsilon naught. So that means, do we have the net field as, you can write it Q by A epsilon naught. That means sigma by epsilon naught also. And if I say these two plates are separated by d distance, so can you tell me what is the potential difference we have created here? Delta V. So because of these two, we got the net field. We got the net field. Of net field, with the help of net field, how do we calculate the potential difference? E dot dr. So net field is how much the net field we have? Q by A epsilon naught, and separation between them is dr. So delta V we got it, right? Now delta V is known. How do we get the capacitance? So remember, capacitance is Q divided by delta V. What is the capacitance? Q divided by delta V. Just check it here. Delta V is known, Q is known. If you simplify it, am I getting the capacitance as epsilon naught A by D? So this is the capacitance of what? A parallel plate capacitor. Okay, what is this? It's a capacitance of parallel plate capacitor. Okay, parallel plate capacitor. And what is the medium we are using here? The medium we are using the vacuum. Okay, now that's why we are using the permittivity of medium as epsilon naught, isn't it? Permittivity of medium we are using as the epsilon naught. That means the medium is what? Vacuum. The capacitance of a parallel plate capacitor having vacuum as the medium between them. Okay, vacuum as medium between them. Understood? Vacuum, you can call it. You can also call it free space. Okay, or sometime air it is called as, isn't it? The capacitance of a parallel plate capacitor having vacuum as the medium is this one. Now tell me, if I change the medium, what will happen? What will change? Is the area of the plate is going to change? No. Is the separation between the plate is going to change? No. But if we change the medium, if we change the medium, then what will happen? The permittivity of a medium will change. Understood? So, what is the permittivity of a medium, or relative permittivity, or dielectric constant? We discussed it. Please tell me. What is relative permittivity or dielectric constant? Relative permittivity is also called as the dielectric constant. Please tell me, what is that? Relative permittivity or dielectric constant, epsilon R. Remember? Anyone?
Yes, sir.
Oh,
Epsilon naught into epsilon naught is medium.
right. Do you remember? Relative permittivity was net electrostatic force in vacuum by force in the medium, right? The 4 pi epsilon naught, है ना? Q1 Q2 by R square, 4 pi epsilon of medium, isn't it? So can I say epsilon R is nothing but epsilon of medium by epsilon naught? Clear? So epsilon R is what? Epsilon of medium by epsilon naught. So that's why epsilon of a medium is what? Epsilon naught epsilon R, or you can also call it K into epsilon naught. What is this epsilon R? Epsilon R is called relative permittivity, and K is called what? Dielectric constant. This K is not the Coulomb's constant. Please keep in mind. This K is not the Coulomb's constant. Here K I am representing with what? Dielectric constant. So epsilon R is what? Epsilon R is relative permittivity, you can say that. And what is the K representing here? The K is representing the dielectric constant. So here sometime they will give you a question that the medium between the two plates of a capacitor is filled by a dielectric medium having dielectric constant as something phi. So that means they have given us what? They have given the relative permittivity as 5 or dielectric constant as 5. Both are same thing exactly, okay? So please tell me what will be the capacitance, okay, if the medium is filled with, if the medium between the plates of capacitor is filled with what? Some dielectric medium. Okay, what is this? This is a dielectric medium, not the vacuum as the medium. So what will be the capacitance now? K epsilon naught A by D. Understood? So you see that what happened because of dielectric medium. Please tell me, instead of vacuum, instead of vacuum, if we change the medium to some other dielectric, what do you see? Do you see the capacitance getting increased? Why? Because dielectric constant is always greater than 1. Dielectric constant of a medium is what? It is always greater than 1. So that's why if we replace the medium between the plates of capacitor with any other medium, or with any medium other than the vacuum, then what happens? It increases the capacitance of the system. Clear? It increases the capacitance of the system. Clear? So here, if you see, we have filled the space completely with the dielectric. Okay. Sometimes we will partially fill it. Means, let's say the separation between the capacitor was something 5 centimeter. 3 centimeter we filled with a dielectric. 2 centimeter we kept it as the vacuum only. Then what will be the new capacitance? That also we will discuss. But for that we need to discuss about the series and parallel combination of capacitors. So little bit later we will do it. Okay. Before that, let's discuss about what is going to be the energy stored in a capacitor. Okay, what will be the charge accumulated on a capacitor whenever it is getting connected with a battery. Okay, so let's discuss the next thing is the charge and energy. Okay, charge and energy stored in a capacitor connected in the circuit or connected with the battery. Okay, so if we connect a capacitor, this is the symbol of capacitor. Okay, right, this is the symbol of what? A capacitor. Clear, these two lines of exactly same length, that symbol is what? For the capacitor. And one bigger line, one smaller line, what is this symbol? What is this symbol? One bigger line, one smaller line. Yeah, that is the battery. Battery has some EMF, है ना? EMF of battery will be E. And this bigger terminal called positive terminal of the battery, smaller is called the negative terminal. Next chapter, when we will discuss about the electrical circuit, these symbols will come many times. Okay. So the capacitor plate, which is connected to positive terminal, that will get positively charged, and which is connected to negative terminal will get what? Negatively charged. So please tell me, what is the potential difference applied across the capacitor? The potential difference applied across the capacitor is E. So what is the charge accumulated on the capacitor? So Q equal to C into potential difference, isn't it? So what will be the charge stored on the capacitor? So Q equal to C into EMF of the battery. Okay, Q equal to charge on the capacitor. How much we got it? Capacitance into EMF. Next will be, what is going to be the energy stored? Okay, what will be the energy stored in the capacitor? So energy stored in the capacitor is going to be half Q into E, we can write it. Okay, or what else we can write it? Q is equal to C also, na? Q is equal to what? C into E also. So C into E, you can write it. So how much it becomes? CE square it becomes. Or what else we can write it? Tell me. Please tell me. E equal to Q by C also we can write it. Isn't it? So Q equal to Q by C we can write it. So that will become Q square by 2C. So if you want to write energy stored in a capacitor, you can use these three: half Q into potential difference, or half C into potential difference square, or Q square by 2C. So when I should use which one? So that depends on the question situation. What is given to us? Let's say in the question given to us, charge on the capacitor is also given, and as well as the potential difference also given. I should use it Q into E, half Q into E. Sometime in the question, only capacitance given, and what else is given? Potential difference applied given. So I should use it half a CV square. You know, if the charge and capacitance both are given, then we should use it what? Q square by 2C for the energy stored, isn't it? So we should always look at the question situation and see what is given in the question to us. Is that clear? Please tell me, up to this part is clear about the parallel plate capacitor? So capacitance depends on shape and size of conductor only, medium in the space between the conductor. It does not depend on the charge and the potential difference. Why? Because capacitance is the ratio of charge and potential difference. So whenever you will change the charge, potential difference will automatically change. You cannot change the charge without changing the potential difference. Understood? Charge and potential difference is going to simultaneously change. And when we introduce a medium, right, dielectric medium other than vacuum, then what it does, it changes the capacitance. What it does actually, it increase the capacitance or it decrease the capacitance. Whenever a dielectric medium is introduced, है ना, when a medium other than vacuum is introduced between the plates of capacitor, what it does, it increases, it always increases the capacitance of the system. Why? Because any medium other than vacuum will always have dielectric constant greater than 1. We don't have any medium whose dielectric constant is less than 1. That's why capacitance always increases if we are putting a different medium other than vacuum between the plates of capacitor. Is that clear?
Yes, sir.
Right. Okay, let's discuss few example here. Okay, the question what is given to us, let's see. Okay, in the question it is given to us, there is a square plate. Okay, what kind of plate is given to us? A square plate is given to us, and the side is given as what? 1 meter cross 1 meter. Side is how much? 1 meter cross 1 meter, like this. It is a square plate. Okay, this is also same thing, 1 meter cross 1 meter. The gap between the plates of these two capacitor is how much? Something 2 centimeter. It's a very small gap. Okay, and it is connected with the battery. These two plates are connected with a battery of EMF 50 volt. Battery EMF is how much? 50 volt. Okay. Initially, the medium is what? Vacuum. Here, what is the medium? Medium is right now vacuum. Find out few things. Find first one. First one, capacitance of this system. Second one, charge on the capacitor. Charge on the capacitor. Third thing, energy stored in the capacitor. Okay, energy stored in the capacitor. Find out these things initially. Next, same these three things we have to find out. Okay, in the fourth part, what we have to do, find all of them again. Find all these three things if if medium is filled by, if medium is filled with dielectric, having dielectric constant as dielectric constant as 5, keeping battery connected. Please keep in mind, this will become a completely different question if battery is disconnected and then dielectric is introduced. But here, what we are doing, we are keeping the battery still connected, and then dielectric is going to completely fill the space. Keeping what connected here? Keeping battery connected in the circuit. Chaliye, please tell me what is the capacitance we are getting? What is going to be the capacitance? Epsilon naught A by D, isn't it? It's a parallel plate capacitor, isn't it? So capacitance is going to be how much? Epsilon naught A by D, we are going to get it. So please tell me what are the values coming to us?
So the capacitance is
What is the unit of capacitance? Farad. Okay, na? What is the unit of capacitance? Farad. Okay. So please tell me what is the capacitance we are getting? The capacitance will come epsilon naught A by D will come. What is epsilon naught? 8.85 into 10 to the power minus 12. है ना? Epsilon naught is what? 8.85 into 10 to the power minus 12. What's the area of the plate? 1 cross 1 na? Divided by what is the separation? 2 centimeter. So 2 into 10 to the power minus 2. So what we are getting? 4.42 into 10 to the power minus 10 unit will come the farad. Okay. Next, first part is that one. Second part, what did they ask in the question? What is the charge? So what will be the charge? C into V, we can write it, na? Or if you want, you can write it C into EMF also, you can write it. So what is the capacitance we have calculated? 4.42. What is the voltage we have applied? 50 volt. So how much it will come? That will become 10 to the power 9, isn't it? And 5 into 2, 0. 5 into 4, 20, 21. 5 into 4, 20. And 22, na? Please check it. Into 10 to the power minus 9 we have. Clear? That much coulomb we can say that. Just check the calculation once. Okay, na? Is it okay? So this is the charge. Third part, they are asking what is the energy stored. So energy is E square or half Q into E. Okay, whichever you want, you can use it in the question. So how much it will come? Half. What is the capacitance? Just check it. Capacitance is 4.42 into 3 voltage is 50 volt. So 50 square we will use it, isn't it? Just simplify it and let's check it how much we are getting. It is coming 2.21 into 10 to the power minus 10 into 2500. Okay, just simplify a little bit. So it will become 10 to the power minus 8. 25 into 1, 25, 2, 50, and 2. So 52, 5, and 55. So 55.2125 Joule we are getting our answer. These are the three things we have. Okay. Now, if I ask you a question that what is going to happen if medium is going to be filled with dielectric having dielectric constant 5. Now tell me what will happen. See, I'm going to make a table kind of. Okay. Capacitance will increase, correct? Here you see battery remains connected. If battery remains connected with the capacitor, please tell me what is the capacitance initially? Is it epsilon naught A by D? And the other side, what I am going to do it, other side I am going to write the value after dielectric is introduced. Okay, one side of the table what we have, before dielectric is introduced. Okay, one side of the table what we have, before dielectric is introduced, what are the capacitance, what is the field, all these things. Second side what we have, after dielectric is introduced, what are these values? Okay, what are these value after the introduction of dielectric? Does it got increased? Does it got decreased? It remains same or not? So these things we are going to plot it. Okay, the battery remains connected. That is the one condition we have here in the question. That battery is what? Still connected. Okay, the battery remains connected. What is this side we have? The values here I am writing before dielectric introduced. Okay, and the right side, what are the value we have after dielectric introduced? Okay, chili, let's see. What is the capacitance before? What is the capacitance before? Epsilon naught A by D. What is the new capacitance? K times of epsilon naught A by D. So can I say the new capacitance? That is the first thing. Second thing, what is the charge? Is the charge C into V? Right. Epsilon naught A by D into V, you can write it. V means a battery voltage, or you can write it the EMF. If you are comfortable with EMF, write it the EMF. If you are comfortable with the voltage, then you can write it the V. Can you tell me what will be new charge of C into E? Please tell me. Understood? So you see, capacitance got increased by K times. Charge got increased by K times. Next thing, energy stored. What is energy stored? Should I use it half CE square? Please tell me. Should I use it half CE square? Do you know why I'm using half CE square? Because as the battery is still connected, the potential difference is constant in this question. So that's why I'm doing it. Okay. What is the new energy stored? Will it be equal to half? New capacitance is K times half KCE square. Fourth thing, what is the electric field? By D, voltage difference applied. है ना? What is the voltage difference we have applied? The voltage difference is nothing but the EMF. What is the new field? Can you tell me? What is the electric field? New value after introduction of dielectric. Electric field did not change. Voltage difference did not change. So what are the things got changed? Capacitance got changed. It increased K times. Charge got changed. It increased K times. Energy got changed. It increased K times. Understood? Electric field, potential difference, these things did not change in the question. Clear? Because of introduction of the dielectric. And as we are keeping the battery still connected across the capacitor, so the potential difference across the capacitor also did not change in the question in the process of introducing the dielectric or in the process of changing the dielectric medium. So please tell me clear up to what we have discussed till now.
Yes, sir.
Right. So let's meet it tomorrow. Again, we will meet it in the evening time. Okay. And we will continue with the uh, mechanics part from tomorrow again.
Okay, sir. Thank you, sir.
right?